Hi everybody, and welcome to our lesson on relation learning. Reveal related insights. Now, relation learning is probably one of the most powerful algorithms that we've developed so far. It serves as the cornerstone of many of our other features, and they will be discussed in later lessons. In this lesson, we're going to tell you what relation learning is. We're going to talk about the prerequisites, and then we're going to give you a little peek under the hood so you can better understand what the computational resources are that you need to run relation learning. We're also going to touch upon all the applications of relation learning in DataMiner, but each of these applications will have their own lesson in this course, so we can make sure you know everything there is to know about them. All right, so without further ado, let's dive in, right? What is relation learning? Why is it so important? Well, relation learning is used everywhere in the field of machine learning and AI nowadays. I think the prime example is ChatGPT, or more generally speaking, the large language models. These models learn relations between any two words of the English language. You can give ChatGPT part of a sentence, such as "the sky is," and ChatGPT will be able to complete that sentence. How? Well, because it knows about relations between words in the English language. When it sees "the sky is," it has a probability distribution to decide which word is probably next. Here you see the probability of the next word in this sentence. Now, it's not really a probability, it's a log probability, but you can interpret it as a probability, and the higher the number, the more likely it is that this word is next in the sentence. And you see that ChatGPT definitely believes that blue should be the next word. A second candidate is clear, and that makes sense. The sky is clear is also a sentence that makes sense. And then you have usually. The sky is usually, and then the sky is the. Maybe the sky is the limit or something like this, right? So this is a very powerful relation learning model if you think about it. Now, not only in the world of LLMs, but also in the world of image recognition, we see a big role for relation learning. Image recognition is typically done using what's called convolutional neural networks. Now, the way they work is they start out by identifying smaller parts of the image. Concretely, if you train a convolutional neural network to recognize a car, the first thing this network will learn is to recognize a wheel, for example. And this is what you see on this picture. We have here a convolutional neural networks, and we have several layers. And in this layer, we see that apparently the network has learned to recognize a car wheel. In future layers, it's then going to learn about relations between these smaller components. For example, assume that your convolutional neural network has learned to recognize an eye. Okay, once it recognizes an eye and a nose, it's then going to look at the relation between eyes and nose. So maybe it's going to say that, oh wait, there are two eyes next to each other and the nose is slightly underneath and then the mouth is there. So this seems like a human being, stuff like this. So again, relation learning is very important here. Now, we are also applying relation learning in our network management, right? Because relation learning allows us to talk about related parameters. And this has various applications in DataMiner. Let me briefly explain. One of the first applications for relation learning in DataMiner is what we call incident tracking or alarm grouping. Here, what we try to do is we try to group together all the alarms related to a same root cause, to the same problem. Now, how do we do this? Well, for example, let's look at this snippet. We see here that the output of the transmitter side 3, let me say the output of the main transmitter side is related to the input of the first slave transmitter side. The algorithm has learned this because it has learned the relation between the output parameter of the main side and the input parameter of that first slave side. And so it knows that the alarms should probably be grouped together. That's just one application. We will give a lot more details later in the course. A second application is about pointing you to related parameters. Assume that there is a problem and you're investigating it. So you're looking at a trend graph and you see, for example, this spike here. Now, at this point, maybe you're wondering, what parameter should I be looking at next? Well, using relation learning, we are able to tell you or propose you which other parameters you could take a look at. That's why we've implemented this light bulb here. If you click on this light bulb, a menu will open up where you can see all the parameters that we propose that you could maybe take a look at. So this can be a huge help if you're investigating a problem. A next application of this is what we call time-scoped relation learning. Again, this will be discussed in much more detail later in the course. In time-scoped relation learning, we're in the following situation. Assume that you're looking at the memory usage on your system, for example, and you notice that there is a very huge spike in memory. It already happened quite some time ago, I see. Now, maybe you want to know which process is responsible for this. Well, this is now possible using time-scoped relation learning. You simply select this part of the trend graph, and again, you see a light bulb appearing. When you click that light bulb, DataMiner is going to propose to you which parameter is most likely the root cause of this spike. All right, that's time-scoped relation learning. A final application of relation learning is in dashboarding. If you know about dashboards, and probably you do if you've joined one of our Empower events or you've checked out some courses on Dojo, then you know that one of the key components of dashboarding is a data source. This allows you to query data and add it to your dashboard. Well, these parameter relations, these relations that we learn, are available as a data source in GQI. So you can simply ask, for example, give me all the relations with a strength higher than 0.99 or something. And this will give you a nice overview in the dashboard of all the parameters that have this very strong 0.99 relationship. All right. Before I finish this part of the course, let me just mention a few prerequisites. As we will see in the next video, relation learning requires quite some resources. You need to learn a lot of relations. That's why we do not run relation learning on your system, but we run it on the cloud. That's why you will need a cloud subscription. Once you have that, you're in business. Simply use the admin app to make sure that you have the model host and cloud feed installed. And also make sure that you allow performance and usage data offload, because we will need to be able to access your change points and your alarms in order to learn relations between parameters and devices. If you don't know how to do this, here are links on the DataMiner docs that you can follow to do this. All right, I can end this now by just mentioning a few resources that you can check out. There's a nice kata. There are some references in our docs with more information. But honestly, if you just follow along with us, just follow this course, you will know everything there is to know about this. All right. Thank you for joining, and join me in the next video where I will be talking about the computational resources that we will need, and I will give you a small peek under the hood of relation learning. See you there.